Hello everyone, here's some extra practice with position, velocity, acceleration. The first one's a calculator problem, and I've already put it in y equals. I've checked the mode to make sure I'm in radians, and I hit zoom 6 just to see what the graph looks like. I do take note that I am between 0 and 10, so I guess I could change that, but I think this is good enough here. You need to know more than what the calculator shows you. Like, I'm not sure if this is an asymptote, but I look at the function and I realize that there won't be any asymptotes, any vertical asymptotes. And I'm not sure if it's going through the origin, so maybe I should check that. Let's see here. I could check that doing second calc value and just plug in 0. And yeah, so it's definitely starting below the origin. Okay, so let's answer some questions. When is the particle moving to the left? Well, that's going to be when velocity is 0. We always want to label your answers. We could use a calculator, so we want to show that we know that that's when velocity is less than 0. We already saw that it starts off below the x-axis. Let's change our window a little bit and make it easier to work with. Let's make x min -1 and maybe lower the y min, make that -5 and 5 and see what that looks like. Yeah, now it's easier to see that there's a root here, a root there, and a root here. So we're basically looking for when this is below the x-axis, which means we're doing a bunch of roots. So second calc 2. I think I want to move it over here. Left bound, I made -1. You can just type that in sometimes if you want, and make that the right bound and enter. And it found a root here at 0.112. So A was from 0 to 0.112. And this looks like it's at 1 to 2.5. So second calc 2 again. Once again, you can just type in the number. I put in a left bound of 2 and a right bound of 3. And, oh, I did not do it far enough. Second calc 2. All right, well, at least I'm there, though. Now, so I can go enter. That's definitely to the left of the root and right of the root. And so it's going to be from 3.029. And then another one, second calc 2 for the root. Here I can just move it over. Once again, I could have just typed in that number if I knew it. Enter. And that's 6.395. And there's going to be one more section where I'm below the x-axis, right? You're moving to the left when velocity is negative. So I want that root also. Second calc 2. Let's see, it should appear on the other side at some point. There we are. Enter. And it's going to be 9.312 till the end, till 10. I always do parentheses because you can't have a velocity at an endpoint, but arguably there could be brackets at 0 or 10, and the College Board would accept both of those. All right, what is the velocity at 4.6? We could just do velocity at 4.6. That means we're going to this is a velocity function, so I can just do second calc 1, find the value of the velocity at 4.6 and hit enter, and I get -1.349. And you should always, at this point, check for units. I don't see any units, so we're good. Let's circle this answer. We should have also circled this answer. C. Notice how I'm labeling everything and jotting down what it is about. What is the acceleration? Well, acceleration is the derivative of velocity at 4.6. So now I can do second calc 6 dy dx. and we have to type in the number. Notice it's close to 4.6, but we don't want that. We want to be exactly at 4.6. Enter, and we get negative 0.017. Once again, no units. D, I'm going to put it over here because we're going to give a reason for it. Is velocity increasing at 4.6? Velocity increasing is a measure of acceleration. So since it's negative, we're going to say no. Velocity is decreasing. At t equals 4.6 because, what do we want to say? Because v prime of 4.6 is less than 0. Answer no. All right. Is speed increasing at 4.6? Now, speed increasing, something speeding up, is a judgment of both velocity and acceleration. So we want to say yes. Speed is increasing. At t equals 4.6 because, and now we want to say, and notice how I'm specific to 4.6 because v of 4.6 and v prime of 4.6 are both negative. You could say, or they're the same sign. Something is speeding up when velocity and acceleration are the same sign. All right, so that was a good calculator practice. This one's without a calculator. A particle moves along the x-axis. Here's a position function. Let's just right away figure out what velocity is and acceleration. I'm sure we'll need those, but who knows? All right, when is the particle moving to the left? So part A, labeled, that's going to be when 2t minus 8 is less than 0. Something moving left or down when velocity is negative. And so that's going to be, here we have t is greater than or equal to 0. So that's going to be when t is less than 4. So let's say from 0 to 4. When is the particle at rest? That's when velocity is equal to 0. So we'll say at t equals 4. Speed at t equals 5 would be velocity at 5, but absolute value of it. All right, and what do we get when we plugged in t equals 5? I'm going to change this to a 3 to make a point here. The absolute value of velocity at 3 would be absolute value of, if I plug 3 into velocity function, I'll get negative 2. And so we'll give just 2. And I don't see any units. The next one will have units at least. All right, when is speed increasing? Speed is increasing. Well, we want to do a signed number line of velocity and a signed number line of acceleration. Remember, t has to be greater than 0. All right, so for velocity, we already figured out that the dividing point was at 4, and that if t will be positive, negative, and acceleration is positive the whole time. All right, so when is speed increasing? That would be from 4 to infinity. This is not enough justification. The College Board has said that the signed number lines alone is not enough justification. You just have to jot down. This is when velocity and acceleration are the same sign. And so I'm labeling everything clearly. This goes with that answer. All right, E. Let's do E over here. When is velocity increasing? that's a measure of acceleration. We're going to say always from 0 to infinity, because this is when acceleration is greater than 0, right? Because it's everywhere. And then finally, F, average acceleration would be, average acceleration, that's going to be change in velocity over time. Although acceleration is just 2, we know it's going to come out to be 2. So that's kind of a nothing burger there. But let's do, acceleration is change in velocity over time. So just to show the work, we would do velocity of 6 minus velocity of 2 all over 6 minus 2. And what is v of 6? V of 6 is 12 minus 4. I'm sorry, 12 minus 8 equals 4. And what's 2? 4 minus 8, which is a negative 4, all over 4, and 8 over 4 equals 2. And I forgot about units here. Let's see if we need units anywhere. A particle moves along the x. Oh no, this one didn't have units. So the answer to F is 2. All right, and then one graph one. This one does have units. Velocity is measured in feet. This is a velocity graph, which means velocity is going to be the height, and acceleration is going to be the slope. And I'll start over here. Part A. What is the velocity at 4 seconds? Oh, that's just 0, right? That's the height of the graph. So 0 feet per second. We want to use some units here. Circle answer, labeled B. What is the speed at 3 seconds? That would be the absolute value of velocity. And at 3, we're at negative 4. And so that's going to be 4 feet per second. What is the average acceleration on 7 to 10? Once again, that's going to be change in velocity over time. So you'd label velocity to 10 minus velocity to 7 all over 10 minus 7. 10 is going to be 1. V of 7, it looks like it's at 2. All over 10 minus 7. So that looks like it's going to be negative 1/3. And units, we don't want velocity units. We want average acceleration units, so feet per second squared. D, when does the object change direction? That's when velocity changes sign. We are communicating our process here. Velocity changes sign at 4. E. For what values of t does the graph of position have inflection points? Okay. An inflection point for the position graph would be when S double prime changes sign, which is when the slope of S prime changes sign. And that's going to be not here because it went from negative to 0, so it didn't change signs there. And here it went from 0 to positive, so not there. So here t equals 5, t equals 7, and t equals 9. That's here, here, and here. Okay. Okay, so F, I think I have room to put up here. F, an object is speeding up when, all right, if this is velocity, when velocity is positive and acceleration is positive, so we're looking for that, or when velocity is negative and acceleration is negative. So from here to here, looks like from 0 to 1. And from 4 to 5. and then from 7 to 9. All right, and fine. Two more questions here. G, when is the object moving to the right? That's when velocity is positive, and that's going to be from 4 to 10 because it's above the x-axis. And then when is velocity decreasing? That is when the derivative of v prime is less than 0. And that's going to be about the slope. So that's going to be from 0 to 1. And from 5 to 7. And from 9 to 10. All right, those were some really good practice problems. Notice how I'm organized. I've labeled everything. I've circled answers. I've used units when it's possible. And there we go. Maybe I should come back in here and circle that. All right, good luck to everybody.